to convert a molecule in perspective into a Newman projection. So for example, let's assume we have a molecule in this perspective form. How do we convert this molecule into a Newman projection? To convert a molecule from a perspective form to a Newman projection, for example, remember that in Newman projections, we have the front carbon and then the back carbon. So now, if we divide the Newman projection vertically into two, then all the groups that comes at the top and then the bottom are the atoms that are in the plane of the molecule. And then all the groups that comes to the right hand side are the dash bond. The dash bonds are the bonds that are going into the plane. So for this bond and this bond, they are going into the plane. And then on the left hand side, the bonds that are put on the left hand side are the wedge bonds. And then the wedge bonds are the bonds that are coming out of the plane. So let's draw this molecule in Newman projection. So this is the front carbon. So this is the front carbon. And then this is the carbon behind. So this is the carbon behind. And then we've said that what comes on top are the atoms that are in the plane of the molecule. In this case, chlorine and chlorine are in the plane of the molecule. So it means that for the carbon atom in front, in its plane of the molecule, is going to be chlorine. And for the one at the back, here too is going to be chlorine. Now, then we say that those that are on the right hand side are the dash bonds, which are the bonds that are going into the plane of the molecule. So the groups of atoms that are going into the plane of the molecule is the C2H5. So it means that for here is going to be C2H5. And then what is coming out of the plane of the molecule is the proton. And that one is supposed to come on the left. So there is a proton here. And then for the carbon at the back, you see that it is the proton that is going into the plane of the molecule. So it means that this side is a proton. And then C2H5 is coming out of the plane of the molecule. So it's going to be on the left hand side. So here is going to give us C2H5. So this is the Newman projection of this perspective molecule. Let's take this molecule and then convert it into a Newman projection. So this is a perspective molecule. Let's convert it into a Newman projection. So this is the carbon in front. So we represent it by this dot. And this one is the carbon at the back. So this is the carbon at the back. And remember, we've said that for the plane of the molecule, it is on the vertical axis. And then the plane of the molecule is protons that are on the plane of the molecule. So this is the plane of the molecule. So this proton is here. And then this one too is here. And then we said that on the left-hand side are the bonds that are going into the plane of the molecule. So they are the dash bonds. So on the carbon in front, you see that the group on the dash bond is what? The bromine. So it means that bromine will come to this side. And then what is coming out of the plane of the molecule is the chlorine atom. So, and then that one comes on the left hand side. So here's a chlorine. And then for the carbon at the back, proton is on the dash bond and proton is also on the wedge bond. So that means that on the wedge bond is this proton. And then on the dash bond is also this proton. So let me draw it. It looks like this. So this is the Newman projection of that molecule that we see in perspective. How to convert from the chair conformer to Newman projection. So let's assume that we have this chair conformer. How do you convert this chair conformer into Newman projections? So what we need to do is that we need to hold the molecule at these two sides. When we hold this molecule at these two sides, you see that these are the carbons in front, and then these are the carbons at the back. So now, we'll be able to draw the carbons in front and the carbons at the back, and then link the various atoms that are connected to it. So now, we see that there is a proton in an axial position here, and there is a proton in an equatorial position here, and then there is also a proton in an equatorial position here, and there is a proton in an axial position over there. So now you can see that this looks in the form of Y, the carbon in front here, and the one here also looks in the form of Y. So what we need to do is that in drawing the Newman projections, let me draw the Newman projections here. We need to draw a Y here, and this is the carbon in front, which is this carbon. And then at this side too, we need to draw another Y. So this is the easiest way to easily convert the molecule into a Newman projection. Then, so this is this carbon, and then this one is this carbon. Now, if we start with this carbon, you see that the proton, this part is this proton. So we put this proton here. And then this part is this OH. So there's an OH here. And then this part is CHF. Remember, there is a proton in the axial position over here. So here is CHF. Then now, let's draw the carbon at the back, which is this one, showing the carbon at the back. And the axial position, there is a C carboxylic acid group. So at this part of this molecule, there is a carboxylic functional group here. And then you can see that to this part is a proton. So this side is a proton. And then this side is a CH2, because there is a proton in an equatorial position here, and then one in an axial position over there. So that's a CH2. So to this side of the molecule, we have a CH2. Then when we come to this part, you see that down here, which is this portion, is the CH3. So there's a CH3 over here. And then to the right hand side is a proton. So that is this part. So to this part, right hand side is a proton. And we have a CHF to the left hand side. So you can see the CHF already there. So let's draw the carbon at the back. So this is the carbon at the back. Now you can see that to the north, to the upper part of that carbon, we have a proton. So there's a proton here. Then to the left, we have a CH2. You see the CH2 is already there, so we need to just connect these two. And then to the right, we have an eta functional group. So this eta functional group is over here. So you can see that this is how you convert a molecule in a chair or a chair conformer to a Newman projection. What about this molecule? So let's consider this example too. Let's convert this molecule into a Newman projection. So the best thing will be to fill up the missing portions or the missing proton on the molecules. So you see that there is also a proton in an equatorial position here, and another one too at this place. Then this is a CHCl, and then this is a CH2. So now you can see that this looks as usual. You need to first draw Y. So there is a Y here, and then at this part of the molecule, at this portion, to draw a Y. So there's a Y here, and there's also a Y there. So this represents the carbons in front, which is this carbon and this carbon. So let's start with the carbon at the left hand side. So you see that to the left hand side, it is bonded to an OH. So there's an OH here. And then to the right hand side, it is CH2, CHCl. Because remember, there is a proton in an easier position over here. So here is a CHCl. Then the down part or the bottom is a proton. So we are done with this carbon. Let's come to the carbon at the back. So this is the carbon at the back. The upper part is a bromo group or a bromine. So we'll show the bromine there. Then to the left hand side is a proton. So this left hand side is a proton. Then to the right hand side, you can see a CH2 here. So this is a CH2 at this portion. Then let's come to this carbon. The down part is made up of a proton. So this is this proton over here. Then the right hand side is a CH3 group. So this part is a CH3 group. Then let's come to the carbon at the back. So this carbon, which is this, the upper part is made up of a CH3. So this is a CH3. So CH3 is over here. Then the right hand side is a CH2, and the CH2 has already been shown. So we'll just connect it to this. And then the right hand side is a proton, which is this proton. So this proton has to come to this side. So you can see that we've been able to convert that molecule or this molecule into this Newman projection. So let's convert this molecule to a Newman projection. You can pause the video at this time and then try. So just as we said, let's fill in the missing portions. So you see that there's a proton here, and also there's a proton here. There's also another proton here, and then there's a proton here. Then there's also another proton here. So now, just as we said, we need to draw the carbons in front by first drawing a Y. So this is our Y. Then you also draw a Y here. So having drawn the Y's, then now when we come to this carbon, so you see that the down part, which is a proton. Then on the left hand side, it is another proton. So this is also a proton. And then on the right is a CH2. So this is a CH2. Remember, there is a proton in the equatorial position and another proton in the axial position. It's the same thing over here. There's a proton here, and then there's also another proton here. So let me cancel this out. So this is a CH2. So this is a CH2. Then now let me straighten this line. So this is CH2. Then now let's draw the carbon at the back, which is this. You see that to the left hand side is an OH. So this is an OH. And then to the right hand side is a CH2. So there is another CH2 over here. And then let's come to this part, which is this. The down part is a proton. And then to the right hand side is a CH2 CHBr. So this side, which is the right hand side, is a CH2 CH and then a Br over there. Now let's draw the carbon at the back, which is this carbon. You can see that to the right hand side is a proton. So there's a proton here. And then to the left hand side is this CH2. So let's join it to this CH2. And then the top part, at the upper part, is a CH3. So there's a CH3 over here. So you can see this is how you convert that molecule into a Newman projection. Let's convert this molecule into a Newman projection. So we just have to continue by supplying the missing portions. So there's a proton here, there's another proton here, and then there's also a proton here. So now let's draw a Y. We always begin with a Y. So this is our Y. And then we also draw another Y over here. So you can see the bottom part here is a proton. So this proton. And then to the left hand side, there's an OH here. And then the right hand side is a CHOH. So this is a CH and then OH over here. And then let's draw the carbon at the back, which is this carbon. The upper part is a proton. Then to the left is also a proton. So there's also a proton here. Then to the right of it, this is a tet butyl group. So let's draw a tet butyl here. So it is a CH33. So this is a tet butyl group. We are done with this side. Then we come to this part. So the bottom is a proton. Then to the right, there is an iodine group here. Then let's draw the carbon at the back, which is this carbon. The upper part is a proton. Then to the left is an OH. So there's an OH here. And then to the right is a tet butyl group. So the tet butyl group is what has been drawn here. So there's a tet butyl group here. So this is how to convert this molecule into a Newman projection.